in ArcGIS Pro, we have two extensibility patterns: solution configurations and add-ins. In this demo, I'll be showing you the solution configuration pattern as well as an add-in that demonstrates the new Utility Network API in Pro 2.1. Let's say that we have users in our electric utility company who are responsible for determining which customers are impacted by planned outages in our electric distribution network. I'm going to show you a focused application that will allow them to complete this workflow. Now, for the solution configuration, I want to customize Pro to give my users a streamlined user interface. Let's run the solution in Pro, and then we'll take a look at some of the code. Now, in a solution configuration, I can override the default application splash screen, which you just saw, the title bar, the icon, and the start page. Although this looks very different, this is ArcGIS Pro running a custom start page. Because my users work in designated service areas, this start page is set to only show those service areas that are currently assigned to this user. I'll click on Naperville to open the corresponding Pro project for this area. Now, as the project loads, please notice the ribbon user interface in Pro. Notice that I've removed all of the default tabs, including the contextual tabs. Instead, I've created a custom tab, including only the feature functionality that my users need. In the dock pane on the right, I've created a custom pane using the Pro SDK. We'll use that to initiate the trace. In this data grid, we're going to show our trace results. And down here at the bottom, we'll show aggregated statistics for count and load by phase for all of my affected customers. Now, here on the map, I've already placed a starting point or outage point. This is the green circle. This could be the result of a geocoded work order, or maybe I just placed it manually. These yellow points, the squares, represent customer service points, or meters. So we're going to go ahead and run this trace. As the trace completes, the data grid populates with the downstream trace results, including my service points with their corresponding meter numbers. The traced features are selected on the map. To demonstrate that these two views are linked, I can click on rows in the data grid, and you can see the corresponding features flash on the map. I'm going to click this one so you can see it in the back row. OK. We're going to perform a second trace now, and I'm going to use the same starting point, but this time I'm going to use the trace to illustrate the ability to return aggregated totals along with the trace. Now, this ability to return aggregated values is an important optimization. Basically, it allows us to perform calculations on the server with the trace, removing the need to make multiple round trips to and from the service to fetch the features. In this way, I can do it all in one click. You can see here we've gotten back 12 customers in the C phase for 1,200 amps of load. All right, let's take a look at some of the code behind those trace buttons. So the API provides us with a trace manager class that allows us to get an instance of the downstream tracer object. Now, the API provides multiple tracer classes, one for each of the traces that are supported by the utility network. The traces require input parameters such as starting points, barriers, and the scope of the trace. These are all encapsulated in this trace argument class you see here. We then take that trace argument and pass it into the trace method. Now, the utility network is completely services-based. This trace, along with any analytics that it might perform, is implemented using a single REST call to the utility network service. So we get back a bunch of elements, and right here I'm adding this to an observable collection. This collection is bound to the user interface through the MVVM pattern. I'm going to take a quick look at our second trace. The setup is much the same. We create our downstream tracer. We build a trace argument. This time the arguments are different because we're going to perform some analytics. We execute the trace, and this time we get back single load values. Again, we're adding them to an observable collection bound to the user interface using MVVM. This time it's showing up on those bar charts. Finally, I want to go back into Pro and run a trace using a different result set, a larger result set. So I'm going to switch to a new bookmark, clear out my existing starting point, and add a new starting point on that line there. Now, because the utility network is based on a web services architecture, the performance scales well with large amounts of users and larger data sets. The utility network provides a richer data model, including containers, structural attachments, like a transformer attached to a pole, and multi-terminal devices. Additional capabilities include network diagrams, sub-network management, and a new transaction model, all accessible through the Pro SDK.